A special case of the remainder theorem is the factor theorem. The factor theorem basically says if the remainder is 0, then x minus a would be a factor. Which makes sense, right? When you have no remainder, you have a factor. So a special case of the remainder theorem is the factor theorem, which just looks at that one time where it's equal to 0. And this is starting to lead us into the idea, how are we going to factor things bigger than x squared? How are we going to quickly be able to find out if something is a factor? So we can look at example 2. And we can find out which of these are factors. So in part A, I would use the remainder theorem. I'm going to let p of x equal this. So if I want to find the remainder using the remainder theorem, I'm going to try p of negative 1. I'm using that because that's really easy mental math. Negative 1 cubed, negative 1. Negative 1 squared is positive 1, minus 6, minus 5, plus 12. It's equal to 0. So I can tell right away that x minus 1 is a factor. Or x plus 1, sorry. I know right away that x plus 1 is a factor since the remainder is 0. In B, 3 cubed is 27. You might say, ooh, the mental math sounds like it's getting big. Maybe I want to use synthetic division here. If I use synthetic division, I would have 1, negative 6, 5. I don't need that plus sign there. 5, 12. And then if we are dividing by x minus 3, I put a positive 3 out here. Bring down the 1, multiply, add, multiply, add, multiply. I get a remainder of 0 again. So we know that x minus 3 is a factor as well. Woohoo! In C, we have a 4. Do you think you'd rather use synthetic division or the remainder theorem? Probably synthetic division. So for C, set up your synthetic division again. Oh, love the smartboard. And now we are dividing by x minus 4, so I put a positive 4 out here. Bring down the 1, multiply, add, multiply, add, multiply, add. Yay! Another 0. You see a pattern here? Are they all going to work? No. You hope so. It feels so good that they work, right? They're all factors so far. But this is math class, and it has to end with a disappointment. So, our last one. Oh, I didn't want to do that. I want to steal this one. There we go. Now we're checking x plus 4, so I'd put a minus 4 out here. Bring down the 1, minus 4. Negative 10, plus 40, 45, negative 180. Oh my goodness. That's not added right. We get a remainder of negative 168. So that means x plus 4 is not a factor. Now, we did find zoom to the entire page here, we did find x minus 3 was a factor, x minus 4 was a factor, and x plus 1 was a factor. What does that mean? That means that x cubed minus 6x squared plus 5x plus 12 is equal to bracket, 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 x plus 1 times by x minus 3 times by x minus 4. And it's factored completely. How do I know that's all the factors? My first term is x cubed. Why would this be that there cannot possibly be any more? If I look at all my first values, x times x times x will give me x cubed. If I add another factor, I'll get an x to the 4. Next question. No, this is really helpful because this leads us to the next question. How do I know without the remainder theorem, without synthetic division, just looking at my polynomial that I would start with, I know we finished it. We're already done. We already know that the 3 factors are there and there are no others. But let's say we hadn't done that. How can I look at that equation and right away say x minus 7 will not work? It will not give me a remainder of 0. I know right away just by looking at x cubed minus 6x squared plus 5x plus 12. But I wouldn't be confident saying x minus 6 might not work. I know x minus 6 doesn't work, but it might work. But I know for sure x minus 7 will not work. How do I know that? Because 7 isn't a factor of 12. If I underline that 12 in purple and I look at my last terms, I have 1 times a negative 3 times a negative 4. That makes a positive 12. But 7 will never work. 6 might work. Yeah, because if we multiply this out, which is some extensive foil, 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 foil thing, the last ones have to match up with your last one. The first ones have to match up with your first one. I just stole them from here, here, and here. Why doesn't plus 4 work? It is a factor of 12, but there's only one combination of values that work to get all the middle stuff to work out. Okay? So one of the things that we're going to do is you're going to find one factor first. So I'm going to, this is still my p of x, and I'm still going to write p of x equals. And let's say you found x minus 3 to be your first factor. If we wrote the division statement after you did b, can you see that your division statement would look like this? X minus 3 times by x squared minus 3x plus 4, because that's what's left right here. And if you were asked to factor it completely, can you factor x? Can you factor this? This is easy factoring. That's old school factoring. What's it going to be? X and x. I need to get a 4. Outside and inside make minus 3. It's got to be plus 1 and minus 4. Or minus 1 and minus 4, sorry, right? Minus, no. Oh, this is supposed to be a minus 4. I was like, it's not working here. This was supposed to be a minus 4. And so then I would need minus 4 and plus 1. There we go. And it factors completely. Now, we had already figured out all the factors because we did a bunch of guessing and checking, or we used the values they gave us, and happened to be that 3 of them worked. But when you're asked to factor completely, you're going to just find one of them, write the division statement, and then when you get down to an x squared, you can factor that old school. Okay, questions for this one are, 10, 8, and 12.